Good evening, AP Chem students. I have a video to hopefully help you with some of the calculations for tomorrow. If you're looking for calculation help for the other lab that's due on Friday, our introductory titration lab, that maybe I can get for you tomorrow, but for now, just the one for tomorrow that you have to start with. So, for instance, I told you you'd have to measure your pH today, and then you'd have to calculate your molarity of H plus ions to find any of the other information that you would need. Okay, so I want to show you what I have here. Okay, so up in the corner you can see some of these equations that we have. For instance, 10 to the negative pH will give us our concentration of H plus ion. And some other things on here that might be useful to you is that molarity, the big M, is the same as moles over liters. So that's a unit change that you might need to know. Okay, so for instance, let's say I had measured a pH of 4.78. Okay, if I do this calculation, then I get some number. It'll probably be a notation, so I just wrote something here. Don't worry about what it is. Okay, if we call it M, let's say this, we know this M is the concentration just of H plus, and it's not going to match the concentration of our citric acid because our citric acid will let go of 3 H plus ions per every 1 molecule. So that ratio is a little bit different. We want to neutralize exactly 25 milliliters of our acid if possible. So we need to know specifically how much to neutralize, like the number of moles, for example. So at that molarity, if I had 25 milliliters of it, I can calculate exactly how many moles there are. So down here, I review this equation. I took that molarity that was calculated above. Maybe I need to move this over. Okay, I split it into the number with the unit of moles over 1 liter. I'm going to multiply that by the volume. That'll cancel out this unit of volume, but it'll leave me with just moles. That's what I want. Once I have that number of moles of H plus, I need an equal amount of moles of OH minus for this neutralization reaction to actually become neutralized. So it won't be complete if those are not equal. Okay, but knowing that, that number will be the same then. So that number I just calculated, that's also my number of moles of OH minus that I need. So if I have that moles, and I know that I want to be able to neutralize it within 25 milliliters, then I'm going to divide it by that volume in liters. Because of molarity units, it has to be in liters. But then I have this molarity of the OH that I want. Okay, so this is the molarity of the solution that you want when you mix it with your acid tomorrow. This is what you want to be able to put in your burette. I only have 0.10 molar sodium hydroxide. So from that, you'll have to dilute it down to what you need. It's going to be a bit more dilute than what I gave you. Because of that 1-to-1 ratio, even though I calculated the molarity of hydroxide, this is the same as the molarity of the sodium hydroxide. If I'm talking about diluting, that's this equation here. Okay, once I want to dilute this, basically what I have is this molarity that I have, and I don't know how much of that I need to start with in order to dilute it up to the volume that I want. So here I use an example with 25 liters, so like technically I want 25 milliliters to neutralize with 25 milliliters of my acid. That would be the most ideal. But instead, you're going to need enough so you can fill up your burette and maybe have more than that. So I'm going to recommend that you mix it for a desired amount of 100 milliliters or 0.100 liters. So you're going to solve this equation, rearrange it for solving for that V1, or you can write it as X. Okay, I want that desired molarity times the volume that I eventually want. So 100, that lets you have some to keep on the side. Divide it by the molarity that I have, and that should give me the volume to start with, and this is what I'll add water up to the 100 milliliters, and this is then after mixing what I would use in my burette. Okay, and okay, I said that. The other thing I wanted to point out to you is that there's more than one way to calculate this. So I showed you and I reasoned through that method. I have one more I want to show you, and maybe I was thinking about this might actually be simpler. You know, sometimes you don't always find the simplest way first. Work smarter, not harder. So if all of that was really confusing and you're just not sure that you'll be able to get what you need, check this one out, see if it's any better, any different. You'll still need to dilute the base down to what you need. But you may find that the math and the thinking about this could be possibly a little bit easier. Okay. So here's what I've got. All right. The other method, if you dilute the sodium hydroxide to the exact same molarity as your acid, so that they have equal molarities, they'll be the same, then we can use that ratio on the volume instead. So for instance, here's my reaction. Remember, we had 1 citric acid, 3 sodium hydroxides makes 3 waters, and then this salt. Okay, so it's going to make a lot more water than our other reactions have, but it's also going to take more base in order to do that. Okay, so comparing citric acid to NaOH, there's 1 of those to 3 of those. That's the ratio, the mole ratio I'm talking about, or the stoichiometric ratio could be what you call it. And if you use that same ratio by volume, it should still neutralize because of that ratio. Okay, I think this is crooked. Hopefully you can pause it and see what you need to see. All right, so then if I'm using that on the volume, maybe I could plan on having 10 milliliters of the acid and 30 milliliters of the base. That allows you to use about 30 milliliters of what you would have mixed and only 10 of the juice. And you can always, if you start with 10 mils, that's a pretty small quantity of juice, but you could always add more water so that the sensor can reach. And technically that changes the molarity when we would calculate it, but the same number of moles will be in the solution, which will still allow us to do this reaction. Okay, and then it allows us just to use all of the equipment. All right. This also might be a good method. You may have seen the note on here. This also might be good because if you're using orange juice, you can't really see through the orange juice very well, so you might want to make sure you are diluting down your orange juice a little bit. If it's a little bit more see-through, your indicator, if you use it, will be easier to be seen, be more visible. When it first changes, you will see that. Otherwise, you can still pick whatever method you choose, whichever one works best for you. Just need to show me all of that work, or at least an example calculation for things you do more than once. For this, you might just want to show me the whole thing, just make sure it's nice and neat. If this isn't making any sense to you, please email me. I'll be checking on and off until I am off for the evening. So before 9 p.m. would be a good idea. If you have any other questions about the other lab, hopefully while you're titrating, maybe you'll get a second. I can answer some of those questions then, before or after class, or even in a video tomorrow. So good luck. If you have any questions on what I just made for you, please let me know. Alrighty.